In this video, we will solve a question on quasi-linear utility function. The question is like this. Ravi's utility function is given as u x1 x2 is equal to twice natural log of x1 plus x2. Given his current income and current relative prices, he consumes 10 units of good x1 and 15 units of good x2. If his income doubles while price stay constant, how many units of x1 will he consume after the change in income? Okay, the options are 25, 10 or none. Okay, so what we are being given? We are being given the utility function like this: x1 x2 is equal to twice natural log of x1 plus x2. Okay, so we have the utility function in which consumer is consuming good x1 and good x2. Okay, this is a quasi-linear utility function. That means it is non-linear in good x1. Okay, non-linear in good x1 and linear in good x2. Okay, linear. Okay, we are being told there he is consuming 10 units of good x1 and 15 units of good x2. Okay, so how do we solve this kind of question? So this is our utility function, and we are being told prices does not change. Let us draw, write the budget constraint here. So we have, let us say p1 denotes the price of good 1 into units of good 1 plus price of good 2 into units of good 2 should be equal to the total income of the consumer. So all the income should be exhausted. Now how do we solve when we have the utility function and budget constraint? What we do, we simply use the tangency condition here. So tangency condition requires that our marginal rate of substitution should be equal to the ratio of the prices. Okay, so actually I have explained the in-depth concept of the quasi-linear utility function in another video. You can check that very video. Okay, so marginal rate of substitution between good 1 2 is simply the marginal utility of good x1 upon marginal utility of good x2. It should be equal to the ratio of the prices. Okay, so yeah, go b1 is 2 at it. Okay, so these are some mistakes I occasionally do. Now, marginal utility of good x1 means that taking partial derivative of this function with respect to x1. So the derivative of ln x1, that means log of x1 is simply 1 upon x1. So we get here 2 upon x1 divided by marginal utility of good x2 means taking derivative partially of this function with respect to x2. The derivative of x2 will be 1. So we are left with 1 should be equal to price of good 1 upon price of good 2. When we solve this will come out to be, so this is 2 upon x1 is equal to p1 upon p2, or we can reciprocate on both sides. So this is x1 upon 2 is equal to p2 upon p1, or x1 comes out to be twice p2 upon p1. Okay, this is the demand function for good x, and here you can see it is independent of income in this question. Okay, so if I plug this, actually I have to plug this very x1, the value of x1 in this. Okay, so it will be still independent of income here. Okay, so we will get only this demand function in terms of x2. Okay, so the basic idea is that we got the demand function here which is independent of income. Okay, so we are being told that income has doubled. Now we need to see how much the consumer will consume of good x1. Okay, after the income has doubled. That means we need to take the derivative of this function with respect to income. That means change in the consumption of good x1 with respect to change in income. Okay, so if we take the derivative of this function with respect to income, since no m is involved, so its derivative is obviously 0 here. Okay, So change in the consumption of good X1 is equal to 0 into change in income. Okay. So change in good X1 ये triangle as बने. So good X1 is equal to 0 times change in income, which is equal to 0. Okay. So there will be no change in the consumption of good X1 after the consumer's income has doubled. Okay. So he will still consume 10 units of good X1. So graphically, what does this mean? The graph of the quasi-linear utility preferences, if I can draw it here, if I have the space. So let me draw it like this. Okay, so the graph will look like this. Let us say initially this was our budget, and let me draw first the quasi-linear indifference curve. Okay, so if this was our initial budget, you know, this is our indifference curve, this is our budget line. After after income has increased, so our budget line will shift, obviously. So let us say this is our new budget line, BL. Okay, new budget line, and in this case our indifference curve will look like this. Okay, so there will be, and the indifference curves will be the vertical translates. Okay, so they will move upwards vertically. Okay, so there will be the vertical distance will be constant in case of quasi-linear utility functions. Okay, so if we have x1 on this axis, x2 on this axis, okay, so consumer and the consumption of good x1 does not change after it has reached to 10 units. Okay, any increase in income will increase. Let us say here we have 15 units of good x2, so any increase in income will increase the consumption of good x2, but not the consumption of good x1. And what is the angle curve in this case? So let me draw it here. So angle curve looks like this. Let us say we have income on this axis, we have the good x1 on this axis. Okay, so initially what happens, let me draw the general angle curve here. So initially consumer will be consuming units of good x1 up to a certain threshold. After that, when he reaches a certain threshold, any increase in income will not increase his consumption of good x1. Okay, so this is how do we solve this question. So I hope I am making myself clear in this video. Thank you.